This video is going to show you how to solve a projectile motion problem where the initial velocity is horizontal. A dog is chasing a ball when the dog runs horizontally off a ledge and lands in the water 4 meters from the edge of the ledge. If the ledge is 2.5 meters above the water, then how fast was the dog running when he left the ledge? Okay, let's start with a picture of what's going on here. So let's see, I'll start with my ledge and then my water. This is not drawn to scale or drawn all that well. Here is my dog, nice and simple, running with some velocity, and that's what I want to figure out. I know that the height above the water was 2.5 meters, and I know the range distance is 4 meters. Okay, so that's what I know. Now, let's see what else I know. Let's start with the list of givens. In a projectile motion problem, it's really two kinematics problems with two different sets of givens. One set of givens is for all the values that are going vertically, that's up and down, and the other set of givens are all the values in kinematics that are going horizontally, that's left and right. So I'm going to start with that. Well, let's see. I need my kinematics givens, so I'll list those as Vox, V, Vox, TVA, Vox, TVA. And I'll start with everything that's going up and down, that's vertical givens. So let's see, what do I know? Initial velocity going up and down, well, it's not going up or down vertically, so that's going to be 0, that's easy. The distance in the vertical direction is going to be 2.5 meters. I know the acceleration is going to be 9.80 meters per second squared. The time I don't know, and the impact velocity vertically I don't know. And what I'm doing here is I'm assuming that everything going in the downwards direction is positive. The distance, if it starts from the ledge and goes down and the acceleration goes down, they go in the same direction, which means they have to have the same sign. So either they're both negative or they're both positive, and I'm going to make them both positive because that just seems to make the math a little bit, or look a little bit prettier. Okay, now let's look at all the givens that go left and right. That is all the givens that are horizontal. So initial velocity, horizontally, that's actually what I'm looking for. I want that to be my final answer. The distance horizontally is the range. That's going to be 4 meters. And the time I don't know, and the velocity, I actually don't know that either. It's going to be the same as V naught, but that really doesn't help me solve anything. And the acceleration is going to be 0. That's why it's the same as V naught. All right. What I'm going to do here is I'm going to find the time using the vertical givens because I have enough there to find the time. And what I know is when I find the time, that the time I find with the vertical givens is the same as the time in the horizontal givens. And then I'll use my kinematics again horizontally now that I'll have enough variables to find out what the initial velocity is. So let's do that. Okay. Find the time. And that's time in the air. And to do that, I need a kinematics equation that'll work with these variables. And I'm going to use my x equals x naught plus v naught t plus 1/2 a t squared. Let's see, x naught is always going to be 0 because we're going to start from 0 in all our problems. Vertical initial velocity is 0, so that's great. And that leaves x equals 1/2 a t squared. Isolate t, I'll multiply both sides by 2, divide by a and square root. So t equals 2x over a, all that's square rooted. Oops, what happened here? Okay. So let's see. That is going to equal 2 times x, which is 2.5 meters, divided by 9.8 meters per second squared. All that square rooted. And that'll give me the time. In this case, to be 0.71428574143 seconds. Okay, so that's great. Now I've got the time over here. It's 0.0714, and all those other decimals go with it. 714, and write all the decimals. Now I can use kinematics to solve this. I'm going to use the same equation, but when I use this equation, there we go, the acceleration is going to be 0 horizontally, and I know that x naught is going to be 0 horizontally. So it leaves x equals v naught t. Now we call that, for projectile motion, the range equation. That's initial velocity in the x direction times t. So that's the range equation. And the range is 4 meters, and I have the time, so it's easy for me to find the velocity. That velocity that I'm looking for is just going to be the range divided by time. So that's going to be 4 meters divided by that long decimal, 0.71428574143. And yes, I do put all those decimals in my calculator. And so that gives me my initial horizontal velocity when I do the math, 5.6 meters per second. So what am I going to do here?